Okay, girls, so last night's homework was we just did common chords and tangents, and it was on page I'm in the right chapter. I'm not in the right page yet. I'm in the wrong chapter. Okay, was it 11 point? No, it wasn't. It was, yeah, it was 11.51 to 10. Yeah. Yeah. What am I doing, if anything? Anyone? All good? Yes. Excellent. Right. Okay. So we'll move straight on. Right. Okay. To the next section. Okay. And the next section is not too bad. Right. Okay. We have. I think we have the worst of it done. Okay. So the next one are chords and circles. Yeah. No. Where am I? Oh yeah. Circles touching internally and externally. Right. Easy peasy. Right. Okay. So wait till I find it. Circles. Where did I put? Oh yeah. Just give me a sec. Okay, you don't have to do it like this. I will go like this for you. Okay, slideshow from front side. Okay, touching circles. Right, okay. So Bo, you were asking me about this one the other day. Very simple. Right, we use the distance formula and we get the distance between the two centres. So we need the centre of each circle. And you use the distance formula and you give the centre of each circle. And if the distance is equal to the radius of the first circle, add the radius of the second circle, they touch externally. Right? They touch on the outside. Does that make sense? Right? So we need the distance formula here. We need the centre and radius of each circle, because we're going to use the two centres to get the distance between them. And we're going to compare it to the radius when you add them. Okay? So I don't think there's anything too complicated in this. Right, so if you're asked, you get the radius of one circle, radius of the other circle. You get the centre and radius of each circle. You get the distance between the centres, you add the radii, and if you get the same answer, they touch externally. Okay, that means they touch on the outside. Right, externally. Okay, so one circle is outside the other, and touch means they meet at one point only. That word touch means they meet at one point only. Right, okay, so they would have a common tangent, going back to what we were doing yesterday. Okay, is that all right? Okay. Right, good? No. So what other way can they touch? Internally. Right, okay, so we'll show you the diagram in just 2 seconds when you're ready. Are we, no, sure? Everyone's ready? Right, next slide. So the next slide is if they touch internally, as in one circle is inside the other, again they touch at one point only. So touch means they touch at one point only, right? Then you still get the distance, you get the centre and radius of both circles. You get the distance between the centres using the distance formula, right? But it should be, this time, you take one radius from the other. The big radius, take away the small radius, should give you the distance between the centres. Right? Is that okay? So, not in the log tables, you need to remember this is what you do. And remember, touch means they hit it at one point only, right? So if you see that word touch in a question, it means one point only. So if it touches a line, that means the line is a tangent, right? Okay. Right, an example. We're all good? All okay? Yeah? Right, so example 1, only example. Show that the circles, there they are, touch externally. Sorry. Okay, ready? Okay, so we need to get the centre and radius of each circle, because if they're touching externally, the distance between their centres is equal to the sum of their radii. Okay, it's frozen, thank you. Okay, and it's nowhere near where it's supposed to be. What's wrong with that? Okay, right, so we need to get the centre and radius of each circle. So here, 2g is equal to minus 1. So, sorry, 2g is equal to minus 2. I'm thinking ahead. G is equal to minus 1. There is no y term, so that means 2f is equal to 0. So that means f is 0. So the centre is minus g minus f, which is 1, 0. Okay? The radius is the square root of g squared plus f squared minus c, so that's the square root of 1 squared plus naught squared minus 15. Okay, so that becomes a plus 15. So it's the square root of 16, which is 4. Okay, right, then over here we get the centre. 2g is equal to minus 14. So that means g is minus 7. 2f is minus 16. So that means f is minus 8. So the centre is minus g minus f, which is 7, 8. Okay, the radius then is, I'll just form it over here, I'll just fill it in. So it's g squared, which is minus 7 squared, plus minus 8 squared, minus 77. So that would be 49 plus 64 is 113, take away 77 is square root of 36, which is 6. Is that okay? Right, now I have to get the distance between their centres. So I have to use the distance formula to get the distance between their centres. Okay, so the centres are 1, 0 and 7, 8. So I'm going to call this one x1, y1, x2, y2. So it's the square root of, I won't bother writing down the formula if it's okay, x1 plus x2 to be squared minus, it's the wrong way around, isn't it? Yeah, it's x1 minus x2 to be squared plus y2, y1 minus y2 to be squared. Have I right now? I should have written down the formula because I don't know it. It's, what is it? So it's x2 minus x1, y2 minus y1, right? x2 minus x1. So look, if I just change this to x2 and y2 and change this to x1 and y1, I'll be right, won't I? x2 minus x1 minus x2 minus x1, y2 minus y1, and there's a plus in the middle, yeah? Is that alright? So I just changed that to this one to x2, y2, and this one to x1, y1, and I'm right. Okay, so then into the calculator that's 36 plus 64, which is 100, square root of 100, which is 10. Okay, is that alright? Okay, and then you have to prove they intersect, they touch externally. So that means the distance between the centre is equal to R1 plus R2. You need to write this bit down, right? So you need to write 10 equals R1 turned out to be 4, R2 turned out to be 6, and you need to write 10 equals 10, and that means they touch externally. Okay, so it's really important to write this bit. Don't leave them put it together, right? Okay, you put it together for them. Is that alright? So the question is, do they touch externally? Yes, they do. I didn't do an internal example because I presume you'd be able to subtract the radii. Yeah, is that alright? Okay, you'd be okay with those ones? Right, as I say, not in the log tables, so you need to remember what to do. Okay, right, am I okay to move on? Right, so the next thing I want to talk a bit is about chords and circles. Now we've talked about chords and circles already. Right, we talked about chords and circles already, and I've already told you this piece of information, but I put, remember, the perpendicular from the centre of the circle to a chord bisects the chord. Okay, so, and there's a diagram of what happens. So in the given diagram, D is the length of the perpendicular distance from the centre O to the chord. We can use Pythagoras' theorem. We've a right angle triangle here. We'll know the radius, right, okay. You'll know either the distance, right, or you'll be able to get the distance from the centre to the chord, or they'll give you the length of the chord and you'll be able to have it. and you'll have the other side of the triangle, okay? And you'll be able to find out what's missing, okay? So, again, we've seen chords like this already, but just, we did a whole section on tangents. This is supposed to be a whole section on chords. I don't know. Right, okay? Is that alright? So, just once you have a right angle triangle, right, and always marking the radii on the circles, because you mightn't spot that you actually know the length of some of the lines. Okay? And the converse of this this theorem is true. It's also true. So if if a line bisects the chord, right, okay, it goes through the centre, right, okay. So if a line bisects the chord, it goes through the centre. Right, good to go. Right, example. Right, okay. This came from the book. So if you want to save yourself some writing, do you want to save yourself some writing? Yeah? No? Right. So if you want to save yourself some writing, it's page 448, question 8. So page 44, so example 1 is page 448, question 8. Right? If you want to write it down, write it down. So page 448, question 8. And if you're not writing it down, make a start.
You kind of like explain quadrants, and like I know there's 4, but isn't there something to do with like degrees in quadrants as well? Like something is like, it's in the 3rd quadrant, it's like, I don't know. I was talking about this the other day and I couldn't remember stuff about quadrants. Are there like...
That's kind of trigonometry, is it?
Oh, okay, that's what I was trying to do, question 3. The exam paper.
Yeah. Can I just say, trigonometry is a gift that's yet to come.
Oh.
Okay.
Okay.
Right. Okay. Yeah.
Is that a message?
Sorry?
Is that the next thing we're doing?
No, I think we're on financial maths next.
Oh, that's not bad.
But it's in order to do financial maths, girls, we have to revise sequences and series. Right? Okay. Now we're not revising it, you're revising it. Okay. Oh, be quiet. Right, okay. So look, the plan is next 2 weeks on financial maths and 3 weeks on trigonometry, which will bring us to Christmas. Okay? And we then after Christmas we're doing all the geometry. We've a bit of integration to do. Right? That's the opposite of differentiation. Very short chapter, should be done in 2 weeks as well. Right? That's 1 week before the pre's and 1 week after the pre's. But when we see the pre's, I might move stuff around, okay? Right, as in, I'll make sure you've everything done that's on the pre, right? Okay, then there's lots of proofs and lots of constructions that we've kind of left out as we've gone along. So I'm going to go back and do them all together. And then you know you have everything you need to learn all together. Right, okay? Is that right? Okay, but like touching, the end is touching distance. The end is very near, isn't it? Because very, what?
That's a bit cynical.
Why?
The end is near.
I don't mean we're going to die, Bo. I mean we're going to finish the maths course. Yeah. Oh, hopefully no one here will die, or anywhere. To be honest, I don't want anyone to die. Yeah, but yeah, I'm not talking about death. I'm talking about the finishing of the maths course, which is yeah. Death might be preferable, but right. Okay, are we good? Right. No. Nearly? Right, okay. So before I start, right, okay, I'm going to draw a perpendicular, right, to this chord. See the way the y-axis is a chord or whatever it is. Is it the y-axis? Yes, the y-axis is a chord on that circle. Would you agree? Because the y-axis hits it at 2 points. It's a straight line that hits the circle at 2 points and it doesn't go through the centre. That makes it a chord. So the y-axis is a chord. Agreed? So if you draw a line, a perpendicular line from the centre, why can't I draw a perpendicular line? Right, okay, I went up too far, then I went down too far. Third time lucky. Or is it? Yeah, it's not perfect, but look, we'll go with it. Okay, so that's a right angle there, right? Okay, why is it a right angle? I drew the perpendicular. I chose to draw a perpendicular. Okay, so that's how I know it's a right angle. I drew it. So I made it perpendicular. So I know.
Excuse me, please, could Sarah Grasson and Carly and Sean will come to reception now?
So I know if I draw a perpendicular to a chord from the centre, what does it do? It bisects, it does make a right angle, but it does something else. Remember, I said remember at the start, what does it do? It bisects the chord, doesn't it? So look, the chord, the length of the chord is?
6.
Is it though? Oh, hang on now. Yeah, it does. It's, yeah, it makes an intercept of, yes, the length of the chord is 6. Right, sorry. So that means there's 3 here and 3 here. So from the 2 red dots, it measures 6, they tell me. Right, okay. It touches the x-axis and makes an intercept of length 6 units on the y-axis. Right, okay. Is that alright? Now, okay, so find the coordinates of the centre of C, right? So we know from here to here, it touches the x-axis. So we know that line from there to there measures what?
3.
No. The line from here to here measures 3. The line from here to here measures 5. Why does it measure 5? Because it's a radius, isn't it? It's a radius. Okay, so that means we have the y coordinate, don't we? So the centre is something 5, isn't it? It's across to here and up to 5, right? If I get the length of this line here, x, right? That's supposed to be an x. If I get the length of this line here, which I will call x, right? won't I have the x-coordinate? Would you agree? Right, so I have the y-coordinate, it's the radius, right? So how do I get the x-coordinate? I use Pythagoras' theorem, don't I? So I might do it here. So it's 5 squared equals 3 squared plus x squared. So that means x squared is equal to 5 squared minus 3 squared, which is x squared is equal to 16, so that means x is equal to 4. Is that right? Okay, so then it says find the coordinates of the centre C, so it's across 4, right, and it's up 5. Would you agree? Okay, easy peasy, but there's a lot of, as in not a lot of work, there's a lot of knowledge gone in there though, right? Okay, so not a lot of work, but a lot of knowledge gone in there, right? Okay, spotting that the y coordinate is the radius, and then spotting, knowing that perpendicular bisects the chord, and Pythagoras' theorem. There's a lot of knowledge in there, not a lot of work. Okay, is that alright? Okay, find the equation of the circle. So we know the radius of the circle, we know the centre of the circle, so it's x minus 4 to be squared plus y minus 5 to be squared equals r squared. R squared is 5, so 5 squared is 25. And it's fine in that form. Okay? So when they ask you for the equation of a circle, that's the easiest one to do. Don't ever go with the x squared plus y squared plus 2gx plus 2fy unless they ask you. Right? And if you wanted to turn it into x squared plus y squared plus, how would you do it? If you wanted to turn that into the x squared plus y squared plus 2fx plus 2gx plus 2fy plus c, what would you do? Square it out, yeah, square it out, tidy it up, right? Okay, so if you wanted to turn that into the other form, square it out, but never voluntarily give them the other form unless they ask for it. Okay, is that right? Okay, all happy with that? Chords and circles, right? Okay, how am I going? I think I'll move on to the next section. Is that alright? That I move on? We're not confused about anything? We're wrapping up a little bit, really. Okay, so I'm still on that, so I don't need to go and change it. Right, okay, the last section is circles touching the x-axis or y-axis. And when I use the word touch, I mean they hit it at one point only, which means the x-axis is the tangent. Right, okay, so I've drawn all these in the first quadrant. Okay, the circle need not necessarily be in the first quadrant. Okay, so the circle need not necessarily, we just use this in the last sum, right? So if the x-axis is a tangent, right, okay, we know the y-coordinate. The y-coordinate is what? The radius, isn't it? Okay, so if it touches the x-axis, we know the y-coordinate. The y-coordinate is the radius. So we know the radius is the same as the positive value of minus f, because remember, radius is length, so it will never have a negative sign on it. So we also know a bit of the centre. We don't know the sign of the second coordinate, but we know the number of the second coordinate, right? Okay, but what we can do is, look, we can fill in, you know, the radius formula. So we know that the radius is equal to the positive value of minus f. Square both sides, that'll give you f squared, right? And when you rearrange, the f squared disappears and you know g squared is equal to c. Now you don't need to remember that, okay? You just remember to do it, right? Okay, right? Is that okay? So when we know, when this circle touches the x-axis, that means the x-axis is a tangent, and the radius is equal to the positive of the y-coordinate. Okay, because radius is length, so it's never negative. So sometimes the y-coordinate could be negative, depending on, like I drew this in the first quadrant, but depending on where it is, right? Okay, are we okay with that? So if they tell you the x-axis is the x-axis is a tangent, you can basically get rid of f's out of any formulas. Right, okay? Actually, that's a lie. You can basically get rid of c's out of any formulas, because instead of c's you can write g squares. Okay, we'll see an example in a while, you know what I'm talking about. Okay, right, ready to go to the next one? What do you think the next one is? Number 2, it's a circle touching the what? Y-axis. So the circle touching the y-axis, this time we know the radius is equal to the positive value of the x-coordinate. Right? So the radius is equal to the positive value of minus g. Okay? So we have a formula for radius equal to the positive value of g minus g. Square both sides. You get rid of the g's and it turns out s squared equals c in that scenario. Right? You're never going to remember this. You need to remember how to do this. Okay? Because you're not going to remember if it's touching the x-axis, g squared equals c. If it's touching the y-axis, f squared equals c. You can't magic that up anyway. You have to show where you got it. Okay? Right? Okay, where Belle's going to go. Okay, so homework, I'll finish this section on Monday. Okay, and Monday after school we'll hit revision. I'll have exam questions for Monday after school. Right, okay, that means Monday after school, if you want to not do Monday after school, you can do the exam questions yourselves, but don't ask me about the exam questions in class, okay? Right, 11.6, 2 to 7, 11.7, 1 to 3. Do you want page numbers, or is that okay? Sorry? 11.7? What about it? 1 to 3. Oh, sorry. Yeah. 11, sorry girls. Here I am pointing at it. Like, I don't know what's wrong with you. Right? 11.6, 2 to 7, 11.7, 1 to 3. Okay? We haven't done the example on 11.7. Have a go. You'll be amazed what you know. Hello? Victory! Do you have a trophy case now to put them into? Girls, if there's any more exam papers, I'll take them because I'll be correcting them this evening. Okay, so, yeah, so if you want to hand them up, if you haven't it up, now's your last chance. I'm not taking them right after today. I'm not taking them. Right, bye girls. Bye guys. Oh, I need to.
Thank you. Right, bye now.